Hello and welcome. In this lecture, we're going to be talking a little bit about water and its relationship with climate change. Now, we've talked about heat before. Now we're going to talk a little bit more about water, but of course we know that the two relate to one another very, very closely. All right, so let's think about the hydrological cycle. Of course, we know that water eventually makes its way to the sea in most cases, or to lakes in some cases. We have a process of evaporation where it goes up into the atmosphere and then eventually returns to the earth through precipitation, right? So this is a normal hydrological cycle that we're familiar with. Now, when we're thinking about water and water accumulation, we are expecting to see some changes. So one of these is sea level rise. So this sea level rise is due to, as we know, the melting of ice on ground surfaces and that draining into the oceans. We also know that as temperature increases, the volume of water itself just increases. And then there's other factors that influence sea level rise with relationship to specific areas, because certain parts of the world are actually dropping in relationship to sea level because of geological factors. So the amount of sea level rise we'll expect in different places will vary somewhat. That being said, predictions are that sea level rise is occurring. We're seeing that's increasing about 3 millimeters per year, roughly. At this point, projections put together by the National Climate Assessment suggests that they might increase substantially more depending on the different types of scenarios for emissions going forward. So that could range from, on average, from a few feet, a foot or two, up to as much as 8 feet in worst case scenarios. And these are substantial changes that would dramatically influence a lot of our coastline. So this is a diagram which is a little hard to see because the area of these coastal areas is not huge, but what you'll see is there's sort of bright blue outline around the outside of the country, and these are areas that are likely to be influenced by flooding or increasing sea level rise. So this might not look extreme, but what we find is the entire boot area, the bottom of the boot area of Louisiana, is gone in this scenario, which is, I think, a 5-foot rise, right? So this could have a dramatic impact, and we also see a lot of Florida would go, and you'll see some bright areas up in Washington State that we'll talk about more in terms of impacts of that sea level rise that could occur. So sea level rise is really important. We know that it's going to impact different parts of the world. There are certain countries, island countries, that are having to evacuate or that are losing major portions of their land area. But another element when we think about water and the potential dangerous effects of water with respect to climate change is that the increase in storms that we'll talk about in a second also leads to flooding due to storm surge. And this is where a storm creates, it's a mixture of two things. One is it creates a pressure surge. So that accounts for a relatively small amount of the surge. But the wind itself can push water ahead of it in the center of this hurricane, and it pushes that shelf of water towards the land. And this can lead to very high sea level surges. So Hurricane Katrina, for example, in some areas had a 25 to 30 foot sea level surge in front of Hurricane Katrina. And part of the damage that we saw as a result was due to that. So here you see that you can have a normal high and low tide, mean sea level, and then you can have these substantial surges in the preceding and being pushed forward by these storms. All right, so remember, we know that there are climate change drivers of storms, and we expect them to be potentially more frequent, potentially having more energy to them. So this is largely due to the fact that the ocean is absorbing a lot of the energy that we're getting from increase in climate change shifts. And that's because water can store a lot of energy. And there's a lot of water that goes very deep that can hold that energy and is increasingly being heated up. And that is really substantial. Roughly, it's about the equivalent of a Hiroshima-sized nuclear bomb going off every second. That amount of energy is being absorbed by the oceans. And we're not really seeing the impacts of this energy absorption on land. If it was just land that was absorbing this energy, we would see about 100 degree Fahrenheit increase in temperature on land. So it's really the water that is absorbing a lot of the impact of climate change. Now, still, even though that increase in temperature in the oceans is slowly occurring, what we're seeing is that we do see increasing concentrations of warm water that increases the rate at which that moisture evaporates into the air and creates more moisture in the sky and creates these more powerful storms. So this is just an example of Hurricane Sandy. You can see the red areas in the map that we're seeing here are anomalous increases in temperature for sea surface temperature. And we're seeing that the red areas are up to about 5 degrees Celsius increase in temperature over normal, over average. So what happened with Hurricane Sandy is you had a storm that came up the east coast of the United States, right in those areas that you see are very bright red, and it turned into the east coast and caused a tremendous amount of damage that took months to clean up. And very large storm, an incredible amount of moisture dropped through rain. And we see large parts of New Jersey. This is a amusement park on the shore that was entirely inundated. We see in Manhattan that there was tremendous flooding throughout Manhattan and Long Island. Electrical system disruption, very, very serious impacts. We also see other examples like Hurricane Katrina, which we see large portions of New Orleans that got flooded and other areas along the Louisiana seaboard. And very serious impacts. As I mentioned, really high sea level surge. I believe it was 80% of the city that went underwater in some form. But again, getting back to some of those social justice questions around this, there was inequity in terms of which parts of the country, parts of the city got impacted worst. So the Ninth Ward got hit the worst due to inadequate levees. Most of this flooding was due to inadequate levees and the fact that they were not high enough to deal with the surge that was dealt with in many cases. And we see that the burden of this impact of this storm was not equally shared across different groups. So we see that in terms of the types of damage, African Americans were almost twice as likely to have experienced the heavy damage from that storm. People who are more housing insecure, renters, were more likely to see damage. People who are lower income or unemployed were more likely to experience that high damage. And you can see that in these impacted areas, it's more likely there was a higher representation of people who are African American, generally speaking. So I'm not going to go through all of this, but there seems to be a very strong relationship going on here. We also see that there was inequity in terms of which areas experience this recovery more. So first off, I should say that your risk of actually dying in this storm, there were about 1,500 people who died in Louisiana due to Hurricane Katrina. Your risk of dying as African American, I believe, was something around roughly twice as high. And we also see that in terms of recovery, areas that were populated primarily by people who were not Black, the recovery occurred faster. So African Americans were disadvantaged in that respect, right? So there's these social justice relationships that are occurring here that we need to stay mindful. And Hurricane Katrina really emphasized this. And there's a really great documentary series by Spike Lee, When the Levees Break, that is worth looking at, that talks about a lot of these issues in more depth. Hurricane Maria is another example of this. Hurricane Maria was a terrible storm that hit throughout the Caribbean, hit Puerto Rico extremely hard. About 155 mile per hour winds, flooding, a tremendous amount of precipitation, and incredible damage to the island. What they saw is that there was tremendous disruption of electrical systems. It took months and months to get electrical systems back up, cell phone coverage. The sanitation systems were overwhelmed. Sewage treatment plants, I think about half of the sewage treatment plants were knocked out by this storm. And we saw really, really extreme impacts in terms of health and otherwise. It's estimated that about 3,000 or so people may have died in this storm, and it's really hard to figure that out exactly, but it's probably at least 3,000 people. Partially due to the impact of the storm itself, but it seems like a lot of that impact actually happened after the storm due to disruption, due to medical responses and energy and other types of things that occurred. So real serious impacts in Puerto Rico. And again, this gets back to the justice issues around the general lack of interest on the part of the government to rapidly and adequately provide relief to Puerto Rico. And it's hard to ignore the racial and language relationship that's going on there in terms of potential probable racism that is related to that lack of response. So again, something to pay attention to here when we're thinking about these disasters. Generally speaking, due to, as we talked about, this increase in overall atmospheric moisture, about 4% at this point increase in overall atmospheric moisture, and possibly more as we go forward, we are seeing an increase in these anomalous precipitation events. So we're just seeing more events that are sort of anomalies in the sense that they're much higher amounts of precipitation. And these types of extreme weather precipitation events could increase by about 400% by the end of the century, depending on how bad of an impact we see. Here's just some of the extreme types of weather that you can see in terms of these supercell storms. This is a supercell storm in Montana that occurred in 2010, and you can just see the dramatic dropping of water. Some of these really storms where there's tremendous amount of moisture can just drop amazing amounts of water. Here's another one that we see in Phoenix. I believe that this one dropped about an inch of water in 5 minutes. So a huge amount of water dropping at once. And this can have tremendous impact on areas in terms of flooding and in urban environments and other environments. Texas has been getting a lot of really serious flooding throughout the state. And here, May 2015, enough rain dropped in order to cover the entire state in 8 inches of water on average. So, we talked about Hurricane Harvey and some of the impacts that occurred there. So we see that there's widespread impacts in terms of health, in terms of the way that states can recover. Fortunately, Texas had some more resources and supports there, but you still see high mortalities and drownings and other types of things that you wouldn't necessarily expect. For example, the fact that there are chemical treatment plants that leak chemicals and toxins and various types of issues like that came out, and those types of things, and sewage and other types of concerns. So real big impacts that we're seeing throughout the United States. And I should also mention here that in addition to the United States, we're seeing this around the globe. It's not just here that is experiencing these very severe weather events. So when we think about this high precipitation, these hurricanes, these floods, what types of things are we seeing in terms of health impacts? And one way to look at this is mortality. Another way to look at this is morbidity. The two are very much related, especially when talking about these extreme events. But in some ways, we could think about them in two different ways. One is direct mortality, and the other is indirect mortality. So direct mortality is mortality caused by the actual event itself, the storm itself. So here are things like drowning or physical injury from the storms or winds, or electrical shock type things that occur, electrocution, that can cause direct health impacts or death in this case. Indirect mortality is really talking about health impacts that could occur actually before, during, or after, that aren't directly related to the weather itself, but are connected to it in other ways. So what might those be? Those might be injuries that occur as you're preparing for the storm, as you're evacuating, or during cleanup. I talked a little bit about chemical releases of various sorts, sanitation, other things that could cause harm. Interruption of electrical power. So a lot of these storms, Hurricane Maria, for example, where you had months without power across, in fact, the majority of Puerto Rico. There's a lot of medical equipment that relies on electricity. There's a wide range of ways in which not having electricity could potentially cause harm. You get up and you trip because you can't see because there's no electricity, and you fall and are injured, or other types of things like that, in addition to the medical concerns. We also see, in terms of transportation, if you can't get to medical care fast enough, there could be harms, or not being able to just access different needed resources is a concern for mortality. You also see, in terms of the indirect effects, these combinations with existing chronic diseases. So are you experiencing medical interruptions? So you're not getting the medications that you need. Is it affecting your ability to get treatment for asthma or other types of considerations that might influence your ability to manage a chronic disease? And then we have psychological harms, in some cases suicide or other types of things that we see in different types of emergency situations. Now, when we compare these indirect and direct impacts, which ones are more dangerous when we think about mortality? Well, it actually turns out that kind of varies. It depends on the storm and the types of impacts that we see. So Hurricane Katrina, most of the mortality was actually due to direct impacts. So mostly drowning, but other types of trauma that were due to that storm itself and the very rapid flooding of the city. Hurricane Ike, for example, it seems like about 2/3 of those mortalities were due to indirect deaths. A very common cause of death was that the electrical power went out. A lot of people were using generators and getting carbon monoxide poisoning. There are other types of, these long-term indirect impacts can also be quite severe, and it kind of depends on how that storm, what its trajectory is. The other question is, when do deaths occur? Do they occur during the storm or after the storm? So again, like before, it kind of depends. For Hurricane Katrina, the majority occurred during the storm. For Hurricane Ike, for example, a majority seem to happen after the storm. So it will kind of depend. We know that for some natural disasters, the vast majority of deaths occur after the storm. For example, if you have a cholera outbreak or typhus or something like that. So sometimes impacts after an event can be much more serious. Sometimes it's the event itself. So that's just important to consider when we think about planning. So what about morbidity or general health impacts that are not fatal? Well, a lot of these factors are similar to the factors that you see for mortality. So injuries, for example, or other types of serious impacts, trauma, for example, that aren't necessarily fatal. But you could also have violence. For example, after Hurricane Katrina, there was some violence. It was widely overestimated in the media, but there was some violence afterwards. You could have water access issues. So can you actually get clean water to drink? In Hurricane Katrina, for example, there was a hospital which didn't have access to clean water, and there's dehydration effects and access to electricity for about 5 days after Hurricane Katrina, right? So there are issues like that. And then you can have sanitation issues and mold and infectious disease that occurs. And the mold, for example, can be something that has a long-term impact after flooding of various sorts. And then we have morbidity in terms of chronic disease and those relationships that occur. And then psychological factors. There's a lot of evidence showing that people, when they go through these traumatic events, actually can have very long-term depression, anxiety, and other factors that they suffer from. And often that is not recognized and treated. So there's a major need for both acute and long-term mental health care after these disasters. Another thing to think about when we think about morbidity and mortality is sort of the ways in which medical interruption can occur due to these disasters. And these are some of the things that we saw following Hurricane Maria, but we see things like access to medicine, so interruption of care. For example, so we see that for a wide range of different types of health conditions. But you also see that, for example, for people who are injection drug users, for example, in Hurricane Sandy, that they don't have, that they go through withdrawal, or they have other types of very serious health impacts in these situations. So it could be medication, it could be vulnerable groups that have other types of addictions or other things like that. So thinking about the ways in which both in terms of access to medicines and other groups will be important. I've already talked about transportation blockage in terms of people being able to access care. Some healthcare facilities might be flooded and therefore close. You can have interruptions to staffing of these medical facilities in terms of being able to actually come into work, or people having to deal with their own challenges in the wake of these disasters. And then we have the range of equipment that requires electricity. And then in these disasters, do people have access to funds that they need to actually get the care that they need is another major question. So there's a lot of different things to think about in medical healthcare systems about what types of impacts you might see. Now, when we're thinking about water, it's also important to think about access to water that people can drink that is fresh and clean. And there are some real serious concerns about this globally and also locally. So when we're thinking about Eastern Washington, we have real concerns about drought and being able to access fresh, clean water in certain areas. So water scarcity is an ongoing problem in terms of having water that you can drink that is safe. This is an issue that affects about 40% of the world population already. As we think about climate change, these types of challenges is expected to increase. Now, there's relationships that are going on here. Actually, only about 12% of water use in terms of like clean water is for domestic use. About 20% is industrial, and about 70% is agricultural when we speak globally. But a large portion of the world, about 1.8 million people, 1.8 billion people, are in places where there's scarcity that you're dealing with, and then you have individual needs bumping up against industrial or agricultural needs, right? And for example, agricultural needs, you also, if you don't provide water to agriculture, then you might have food shortages later on. So there's complex relationships that occur there. We also expect that need for water will increase as we go forward into the century. So we expect in developed nations that the increase in use of water will go up by about 50% over the century. In developing nations, more like 20% or so. So there might be also increased draw of water going forward. Now, the relationship with climate change is that as temperatures rise, you need more water. You need more water for people, crops, energy production. Industry will use more, and animals will use more because of those increases in temperatures and needs for hydration. So when we look at the parts of the world that are really in danger from this water scarcity, there are a lot of countries that could be seriously impacted. So I've already said that about 1.8 billion people live in these countries, and you can look at some of these high population countries that live within the zone. This zone marked off in red is countries that you can expect about 6% of the GDP being lost over the century in sort of our business as usual scenario. So water scarcity is a real challenge, and it may actually lead to climate refugees. So the UN has estimated that somewhere between 25 and 700 million people may need to migrate due to lack of water in certain parts of the world. All right, so let me turn my attention to Washington State, because I think that it's helpful to talk about this concretely within our particular region. So a lot of this data, again, is from the Climate Impacts Group, but estimates suggest that we will experience sea level rise within Washington State. And the range of that, the amount of that sea level rise varies between 4 and 54 inches. So it kind of depends on what scenario we're dealing with. That's up to 4.5 feet roughly within the century. So that can dramatically impact our state, because a lot of our state has low-lying areas near the ocean where you have these floodplains where flooding can occur into the land. And there's ways to address this through protecting our saltwater wetlands and creating barriers and other types of ways of addressing this, but it is a concern. And I've already mentioned that certain tribal areas are being flooded, and some this is leading to some relocation due to the rising water, and particularly when we're talking about surge water. So surge when it comes to ocean is also really important, because as you have the surge of ocean water, you have an increase of sea salt in land that used to be used for agriculture, and that can be very damaging to a lot of crops, and in some cases prevent them from being grown. So these are significant concerns going forward into the century. Now, just to review, when we're talking about precipitation in Washington State, we have this sort of unusual precipitation marine climate that is due to the relationship between the Aleutian Low and the Pacific High, and the way that channels water into Washington State. So we do have that a large portion of the year being quite wet. Again, we also have a fairly unique, well, not unique, but a specific way in which this occurs, because we have these very large mountain ranges very close to the ocean. So we see that the mountain ranges, Olympics and Cascades, cause a fair amount of precipitation, so that the western side of the mountains is fairly moist, and then the eastern side becomes quite dry. So eastern Washington being quite dry, a lot of their water coming from the glaciers that are in the mountains themselves. So in terms of overall precipitation for Washington State, our predictions actually are not seeing a huge increase in precipitation for the state. We're seeing, somewhere between 3 to 10% if you're looking, or like maybe 2 to 10% if you're looking at the bottom and tops of the more likely ranges here, depending on the different scenario that you're looking at. All right. That is a fair increase in water for an overall state, but it's not as high as perhaps some other areas. That being said, we do have some very high extreme weather in terms of water. So here's an example of an atmospheric river where we had some of the highest, the wettest periods of time in the October-April period, where there was channeling of a tremendous amount of water through the atmospheric rivers right into the Washington area, creating a lot of flooding and other types of water events. So although we're having about a 5% increase roughly of water in Washington state, what is expected is that there will actually be more extreme precipitation events. So it's more likely that we'll have a large amount of water being dropped within a 24-hour period. So we expect those more extreme rain events to increase about 22% by 2080 in sort of the high emission scenarios. So there's a real possibility that we'll have more of these extreme flooding oriented type disasters in our region. So if you look in our region, there actually are a lot of low-lying areas along the rivers and coastal areas in Washington state. So here's a chart really showing those areas. So anything that's in that dark blue is a part of the state that is essentially in floodplains. And I think that's areas, anything that's in blue is an area that I think is 10 meters above the river level or water level of those areas, or that in that floodplain. So this is large portions of the area, highly populated areas that are at substantial risk for flooding in our region. So we're seeing a lot of this. This is just some pictures in Carnation, 2015. Some flooding due to the river there. Stanwood, also in 2015. We see Duvall, 2015, really serious flooding. We actually just had a flood like this just last week, where I had my friend who lives in Duvall show me pictures of her actually just boating through a farm where you could see she was actually boating through a greenhouse, and it was just entirely flooded. So we're seeing these types of flooding fairly regularly and fairly severe events. And this type of heavy rain can cause a fair amount of damage. So we saw road damage in Mason County, 2017, the rains that we talked about there. Ferry County, 2017 also, erosion, structural damage, road damage. And unfortunately, we also know that this water can have real serious impacts. In 2015, we had a situation where there was a large amount of precipitation leading to the also mudslide that caused 44 deaths. And this is a mix of high precipitation, some deforestation type issues that led to the destruction of Oso. And these are one of the most severe avalanche type events mudslide events in Washington state. So these are all serious things to consider in terms of the types of vulnerabilities that we're experiencing here. I want to turn my attention a bit to the glaciers in Washington state. So when we're thinking about water, we have an issue that a lot of our water supply comes from these glaciers. So we're seeing that a lot of these glaciers are reducing in size quite a bit already. So this is a picture of the Banded Glacier in North Cascades in 1960, and here we see the same picture, 2016. So we're seeing real reduction in these glaciers, and this snowpack is really crucial to Washington state water systems. So it's really important to our area of the state, but it's particularly important to the eastern part of Washington, where a lot of their water supply relies on runoff from glaciers. And we saw in the drought experiences, which we'll talk about a little bit later, that in really high heat events where we don't get enough when we combine inadequate snowpack with high heat events in the summer, we can have really severe impacts on agriculture and communities in eastern Washington. Now, overall, when we just look at this sort of impact, just to get numbers around this, we're seeing about a 56% decrease in glaciers between 1900 and 2009. And then the area has declined substantially since 1980 as well in the Olympic Mountains, not just the Cascades. So the other thing is sort of the timing of this. So we're seeing that the period of time in which these glaciers are melting is expanding as we have warmer summers. And we also see that in terms of the way in which summers occur here. They're occurring earlier and earlier. So overall, the snowpack that we rely on is expected to decline by about 70% by the end of the century. All right, so here's just a image showing what this looks like in terms of snowpack that we can anticipate for this region. Just to understand what this picture is showing you, the green areas are rain-dominant areas. So, for example, in low-lying areas around Seattle, for example, we don't get a lot of snow. We actually get a lot of rain. As you go up higher into the orange areas, you see a mix of rain and snow. And then up in higher areas where you see it as being blue, that means that typically during the winter, you'll typically be seeing snow, not rain. And these are areas where you can have huge amounts of snow. So, you can go snowshoeing up in the Cascades and be on 10 feet of snow. Very large amounts of snow up there. So what we see is as we go forward to 2040, 2080, that there's a real transition in terms of where the snow dominant and mixed rain and snow dominant areas are. And by 2080, these projections are suggesting that we will have a much more limited area, if any, that still have that snow dominant component to it. So this raises serious questions for us about how we are going to manage our water supply going forward throughout the century. This also relates to sort of the water supply in the Puget Sound area. You can sort of see that the rivers that supply a lot of our water to these areas, it kind of varies depending on where that water comes from. So if it's a river that is coming from rain-dominant areas, we don't see a huge difference. We just see sort of an increase in winter rain that is partially due to that general increase in precipitation that we'd expect to see. In terms of mixed rain and snow, we see that those rivers are substantially shifting in terms of having much more water during the winter and less during the summer, because the summer, a lot of that was snow runoff. And then we see an even more extreme shift for rivers that were primarily supplied by snow and glaciers, where a lot less of that water is going to come from the glaciers. So that shifts what our water supply will look like during summer months. And overall, we expect that summer stream flow will decrease by about 22% by 2050 and 24 to 30% by 2080. The other thing to pay attention to here is as we see increase in the temperatures, the water temperature is also anticipated to increase. And this has really big impacts for wildlife, for example, salmon, for example. So I talked before about the issue around how our state is set up and the way that our geography has a huge impact on water supply, where the Olympics and Cascades influence where water goes. And we'll see that to the west of the mountains, that a lot of the water precipitation occurs in the Puget Sound area, and that we actually are much better off, generally speaking, when it comes to water. And we actually saw this, for example, in the 2015 drought, which probably many of you remember, which was in August of, this is just a picture in August in 2015. It was a state emergency where we had a severe drought even here in Puget Sound, but we had extreme drought, particularly in eastern Washington and some on the peninsula as well. So we do see these types of effects where in eastern Washington we had a lot of crop loss. They estimate that there was about $700 million in agricultural loss in eastern Washington. Here's lakes that were drying up, and seeing the lack of water for those regions and the impact on ecosystems in those areas. So these are some of the things to think about when we think about Washington and the ways that water interacts with our systems here in this state. But I think it's also important to note that there are a lot of things that we can think about with respect to adaptation. And these are sort of general prevention adaptation measures that we can pursue. And some of them are sort of structural changes that we can consider. So when we think about civil engineering and architecture, we can design buildings to be more resistant, design buildings to have better runoff systems. We can design the way that ground cover is designed so that there's more porous surfaces, so there's better water absorption. We can design waterfronts better to create more protection and create natural and man-made barriers, for example, restoring wetlands to create barriers for surge or other types of concerns about flooding. These natural man-made barriers can also be used in dealing with river and stream flooding. And some of these natural barriers involve planting trees, for example, or other types of greenery that we could add. Thinking carefully about our water drainage systems so that we have them in place to deal with these floodings that we can pretty much expect to be occurring going forward. Also thinking carefully about sewage and how we manage that in the context of flooding that will overwhelm these sewage systems that rely on sewage being able to be released, right, in flooding situations. We also need to think about the electrical grid. Real serious issues occur during flooding where electrical grids can be knocked out. And we need to make sure that our healthcare system is prepared for that and that individuals are prepared for that. We can also think about road design so that we are less vulnerable to roads being blocked off to prevent those transportation issues. We can also think about clean water, so that connects into sewage, but ensuring that our water systems for gathering water don't get overwhelmed by flooding so that we can continue to have clean water during these disasters. And in some cases, we need to think about relocation. There might be certain places where realistically our changes to structures aren't going to be adequate to create an adequate level of risk for those areas. So in some cases, we may need to think about moving certain spaces, particularly really important spaces like hospitals or other types of places that are needed during situations of floods. We can also think about broader sort of systems adaptation and prevention things to consider. So thinking about ensuring that our healthcare systems are prepared. So I've already talked about a bunch of different considerations that we need to think about for ensuring that people have chronic care, taken care in terms of chronic care, that we are prepared to deal with different types of trauma or drowning or other types of situations that might have impacts in those situations. Also making sure that our medical personnel and emergency response personnel are trained to help people in these situations. We can also build models to try and estimate what is going to happen to different regions in certain types of situations. And these mathematical models that use different scenarios to try and predict what will happen can actually be really helpful for helping us figure out where to allocate our resources. We can also think about, based upon what we know about different risks in different areas, create early warning systems for flooding or other types of natural disasters. And this can be really beneficial for helping people get out of harm's way and change their behaviors. We can also think about monitoring these different types of impacts and evacuations to make sure that we know where people are going, so that we can and what types of risks are being experienced, both so that we can help people in terms of recovery, but also so we can help prepare for future events as well. We can also think about how we try and make sure that we have funding available for this emergency response, and that we have